Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 28 in our improved Arduino tutorial series. So I'm going to need you to pour yourself a nice big mug of iced coffee. I'm going to need you to get out your fabulous eLego Super Starter Kit. If you haven't picked up one up yet, look down in the description, click on the link, hook a brother up, order it. $35. It has boatloads of components in it, and this entire series is based on the hardware in that kit. And it actually makes it a little better and a little easier for you to follow if we're using the exact same hardware. Okay, what we are going to do today is we are going to do a project where we incorporate a push button into an Arduino project. And this is kind of a follow-on to lesson number 27. Remember in lesson 27, we had it hooked up where we learned about pull-up resistors and pull-down resistors, and we basically, let me move over here, we figured out how to create a circuit where we were using a pull-up resistor, and then we connected it to connected the Arduino to an LED through a current limiting resistor. And then we had it set up in lesson 27 where if you press and held the button down, the LED came on and stayed on as long as your finger was on the button. And then when you let your finger off the button, it would turn back off. And so that really was a very, very simple program. And then I gave you an assignment, and that assignment was to keep the same circuit, but to come in and create a different kind of switch using the same hardware, and that is a toggle switch where if you press it, the light comes on, and then when you press it again, it goes off, so it switches from on to off. Now we're demonstrating this with a simple LED, but you could use this same concept to control all types of different things on an Arduino project. And so what your assignment for today was to create something like this. I press, the LED comes on. I press again, the LED goes off. I press and hold, and it comes on when I let it off, or I can press it quickly. Okay, so do you see what the goal is? The goal is to do this. Were you able to do it? Well, I'd like to hear in your comments below whether you were successful or not. But my guess is many of you were not successful because the first one was so easy, you probably jumped in and thought that this new one that I had assigned you would be easy as well. But it turns out that it's really kind of a hard thing to do. You've got to think in new dimensions and new spaces that you hadn't thought in before. But don't worry. I mean, if you want to still pause and go away and try to do it, pause it, go away, try to do it, and then come back and follow along with me. Leave comments down below. Did you get it by yourself, or did you have to kind of watch me to be able to figure it out? But this is a pretty good lesson. Okay, first of all, just as a reminder, go back and watch lesson 27 if you haven't seen it yet. But if you're one of those guys that doesn't like to go backwards, just wants to go forward, this was the circuit that we hooked up. Push button, one leg of the push button switch goes to ground, the other goes through a 10K pull-up resistor to a fixed 5 volts. And then off of this connection here, we come out to pin 12, which we're going to read a digital signal from pin 12. And then, of course, the LED, we connected to pin 8. We went across a 330 ohm resistor across the LED into ground. So you can pause it there and try to copy that. I'm not going to rebuild the circuit since I already did that in lesson number 27. So today, we are just going to be working on the code, So I need to move to a different and more suitable view. And probably also, before I start coding, we are going to have to kind of talk about what a strategy is on this, because I would imagine that there's a pretty good chance that you just kind of wandered around in the dark for a while on how to do this, but maybe you didn't. Maybe you guys figured it out. But this is what the problem is. You remember that when it is just sitting there, like if you were just sitting there reading from that pin, from from that pin, which pin were we reading from? It was pin 12. If you were doing a digital read from pin 12, what would happen is that if you were just sitting there reading in the no button push state, it's going to be reading ones. And so as you do not have the button pushed, it is going to just be reading ones. And so you're just making a series of reads very quickly. Now, when you press the button, now all of a sudden you will be reading zeros like this. Okay? And then when you let the button up, you're going to be reading ones again. And this is pretty much, we showed this working in lesson number 27. So this is the signals that you have, and this is what you've got to write your program around. And so what is it that you want to happen? Well, this is kind of a down transition, and the way I showed this working is on the up transition. On the up transition, this is where you want to change. So we are going to have to switch the LED on this transition. Now, notice I didn't say turn the LED on, because like the first time you let the button up, you turn the LED on. But the second time that you see the button come up, you have to turn the LED off. So there is a concept here that you're going to have to kind of introduce yourself to, and that is that we need to keep track of the LED. We need to keep track of the LED state. Okay, so in order for this project to work, you have to have a variable where you remember, are you already on or are you already off? Well, if I'm already off, when I come like this, I want to turn on. But if I'm already on, then when I see this transition, I want to turn off. And so we need a variable called LED state, and that is either a 0 or a 1. That LED state is either a 0 or a 1. A 0 would mean I'm presently off, and a 1 would mean I'm presently on. Now, besides that, what you got to see is in the earlier lesson, you were only worried about the present value of the switch, that up here the button is not pressed, and down here the button is pressed, and so you're only worried about where the button is now. But now you've got to know two things. You've got to know where it was before, and where it is now. And that way you can compare the present state to the previous state, and if the present state is different than the previous state, then you want to switch. So we have to have, I guess, we have to have two values for the button. So we would say, I need to know button old, and I need to know button new. So when do we switch? Well, we switch when we see that if button old was 0 and button new is 1, then we want to switch. So we switch on this transition. Button old, the previous reading was 0, and button new, the present reading is 1. Then we want to switch. Well, now what does it mean to switch? Well, if I was a 0, I want to go to a 1. If I was a 1, I want to go to a 0. And so that what that's saying is, if the LED was off, turn it on. If the LED was on, turn it off. So you see how with this, even though this project seems incredibly similar to the very simple code that was in lesson number 27, this one's turning out to be kind of like a lot more that you have to think about, that you have to remember where is the LED presently, and then you have to remember what was the previous value of the button. And so there's kind of like two variables associated with the LED, two conditions associated with the LED, and then you have to have two variables associated with the button, where the button was last time around, where the button is this time. So let's try to begin to set that up. So what I'm going to start with is I've got to keep track of where the LED is. Is the LED on or is the LED off? So I'm going to call it LED state. And when the program first starts, the LED is going to be off, and so I'm going to set the LED state to 0, just indicating we're starting with the LED off, like that, okay? So that's one variable. Now, we also, just like we always did, we have to have an LED pin, and in my case, for this circuit, the LED is connected to pin 8, so we'll call that 8. And I also have a what? I also have a button pin. Okay, my button is going to be connected to a pin, and that button pin is 12, and that is where I am reading that value between the resistor and that one leg of the switch, as seen in the circuit diagram I showed you a while ago. So, but LED pin 8, button pin 12. Now I've got to keep track of what the value of the button is. And I've got to know where it is now and where it was before. So where it is now, I will call that button new. And button new I will read, so I won't put a value on it. And then I also need button where it was before. The last time around, that was button old. And I'm just going to go ahead and set button old to 1, because remember, it's just sitting and reading a 1 before you press the button. So we're going to kick things off with a button old value of 1. All right, we probably will need a little delay in there, so I'm going to put a delay time equal 100 milliseconds, and then I think that is probably the variables that I am going to need. So now in our void setup, we need to do our what? We've set up our serial.begin 9600, so we've turned our serial port on. What do we need to do? We need to do our pin mode. So I'm going to have pin mode, and then I'm going to have LED pin. And what is that? That's an output, because I am sending signals to the LED. And then I'm going to have pin mode, and this is going to be button pin, and that's a what? Input. I'm reading from that pin. So I believe that we have our pin modes done. So now we got to come down here and we've got to start domain code. So what is the first thing that we need to do? We need to read, and we need to look and see whether the button is pressed or not. So that would be a read. And where is that going to go? Well, that's going to go in button new. So what is the new position of the button? The new position of the button will be a digital read. Where are we reading? We're reading from button pin. I feel like I'm going too fast. And guys, if you're not keeping up, watch lesson 27, because I explain this in lesson 27. I explained the basics of the circuit and the basics of doing this read. So we're going to do a digital read of button pin, and there is only one parameter on a digital read, and that's where you're reading from. Now, what is the case that we are looking for? We're looking for when the old value is 0 and the new value is 1. So the if statement that we are going to have is if the old value, button old, was a 0, and a second condition. How do we do and in Arduino? And the second condition is button new equal what? Equal 1. Then we would want to do the following. So does that make sense? What is this transition? If the old value is 0 and the new value is 1, then we want to switch. So that is the condition. If old value is equal to 0, button old is equal to 0, and button new is equal to 1, then we want to switch. Well, what would it mean to switch? That depends on whether you're presently the LED is on or if presently the LED is off. And that's why we set up this LED state. LED state 0 means the LED is presently off. So if LED state equals 0, indicating that the LED is off, then what do we want to do? Well, what we want to do is we want to digital write. What do we want to write? LED pin. And what do we want to do? Well, if it was off, we want to turn it on. So we'll say high. Okay. Now this is pretty important. You're keeping track of, is the LED off or on? Well, it was off. You just turned it what? On. So you better leave a little breadcrumb and keep track that now LED state is equal to what? 1. Okay, so that is the first thing. If LED state is equal to 0, you do these commands. It starts with this open curly, it ends with this open curly. Well, if not, the word is else. Else, that means if LED state is not equal to 0, else, the opposite, the other case, what would we do? Well, we would do digital write LED pin what? Well, if LED is not off, then that means LED is on, and if it's on and we want to switch it, what do? We say low, we turn it off. And what else do we have to do? If we turn it on, if we turn it off, we've got to make sure that we remember now that LED state equals 0. So we have got to keep track of these things, and I am doing a horrible job in putting my semicolons in. So let me go back and do this. Okay, so what are we going to do? We're going to read the button, all right? And if the previous value of the button is a 0 and then the new value of the button is a 1, then we want to switch. Well, what do we want to switch? Well, if the LED was off, we want to turn it on, else, that means that it was already on, then we would want to turn it off. And then we've got to make sure that we keep track of whether we are on or off. So now we are coming out of all of these if statements, and so this curly bracket ends that curly bracket. After we do this, what do we need to do? Okay. We need to remember what the new value of the button was, but now that new value becomes what? It becomes the old value. So button old now is equal to button new. And then what will I do? Okay, I put the button new into the button old, and then I come up and I read a new button new. And so we have this all programmed in. Let's go ahead and see if we can download this. This is a crazy one, so I need everyone to hold their breath. Oh, no. What did I do? Oh, delay time 100. Why did it not like DT? Ah, I forgot to say int. I never used that yet. I never used that yet. And that reminds me now that I fixed that you don't want to run this thing too fast. Because what can actually happen in real scenarios that you often had trouble with push buttons, because when you push the button, it doesn't cleanly come down. A lot of times it will sort of jump up and down a few times. And this is called bounce in a switch. And if you're sitting, this would go on, off, on, off, on, off real quickly a lot of times with a button push. And so what you want to do is you want to have a little bit of delay to let that clear out and not negatively impact your performance. So after we do all this, we don't want to go too fast. So I'm going to say delay, how much delay time. And then let's go back and look at what our delay time was, 100. That's 1/10 of a second. So I think the circuit will still be pretty snappy if we do that. Okay, problem was someone didn't hold their breath. That's why it didn't work. All of you, I need you to hold your breath. PIM mode, it's important to spell correctly. Were you guys yelling at me on that? Okay, this time, seriously, everyone hold their breath. going to work. Yes, it's going to work. Okay, it downloaded. And so now let's come over and let's look at a more appropriate view. Let's see if we can come up to this shot. And now we have downloaded the code. And now I'm going to come over and I'm going to press the button and let my finger off. So I'll go like that. Ha! Boom! The light is on. The LED is off. I can hold it down a long time and let it off. You see, it doesn't switch when I'm pressing down. It switches when I let my finger off. And that's what we were doing, right? Remember, we were looking for that. We were looking for that 0 to 1 transition. And we can see that it is working most excellently. This is a very, very powerful thing because usually you want a switch like this, a push button switch, to operate in the toggle mode. You usually want it to operate in the toggle mode because you could be turning a fan on, you could be turning a motor on, you could be turning any number of different things on and off. And the way you would typically want it to be done is with a toggle switch. Okay, guys, this was I really want to hear excuse me, I really want to hear from you guys. Were you able to do this on your own, or did you have to watch me do it? And if you did it on your own, did you do it this way or did you do it a different way? Because this was not an easy transition from lesson 27 because there were two things you had to think about. You've got to keep track of two values of the button, where it was last time and where it is this time, hence button old and button new. And you had to keep track of where the LED is. Is the LED presently on or is the LED presently off? And so this required a little bit more multidimensional thinking than things we've done in the past. Leave a comment below and let me know how well it went. Love you guys to give me a thumbs up on the video. Would love if you subscribe to the channel. Okay. Appreciate you tuning in. This is Paul McWhorter from TopTechBoy.com. I will talk to you guys.